Video, I'm gonna walk you through the gameplay for our data structures project, in which we got to construct a computerized version of the popular game show network Wheel of Fortune game. I'm gonna walk you through a few of the classes, show you a few methods, and walk you through the gameplay. Note that instructions on how to play the game can be found in the user manual. So first, we have the card class that is used for the wheel. We have the contestant class, also known as a player class. We have the guess class for the letters that the player guesses. We have the puzzle class for the puzzles. We have the cue class for the letters that the user has guessed. Note that we were required to add the letters in a queue, so that's why we had a queue class, and the queue class has method to display the letters, a search method that checks if the letter that the user guessed is already in the queue. We have a DQ function, we have an NQ function, and we have a destroy function. We have a node class to add all the things to the node to create the linked list class, in which we add a method circular linked list. We use circular linked list for the card, the contestants, and the puzzle. Circular linked list would be the most appropriate for the card. Some might wonder why we use circular linked list for the contestant, because the player are selected basically in a circular motion of player 1, then to player 2, then player 3, then back to player 1. So a circular linked list would be ideal and more consistent when selecting player. And the puzzle now, we choose to select the puzzles at random. So in a circular linked list, each list is linked to a previous and the next, including the head and the tail. So when we select a puzzle at random, we remove that puzzle from the list. So when we select the last puzzle in the list or the first puzzle in the list, the first puzzle in the list know where the last puzzle is. So when we remove the last puzzle, we add the previous, we link the second to last puzzle to the head when we remove the last puzzle. If we didn't use a circular linked list, we would have to do a lot of checks. We would have to check whether it is the last puzzle in the list or the first puzzle in the list. But when using a circular linked list, we don't have to do that extra check. So that is why we use a circular linked list for the puzzle, even though we could have used a different method. This is the method that we use to select the puzzle at random. So we pass this function, accept the index, which is generated from a random number for the puzzle that we want to select, and also accept the total amount of puzzle. Reason for passing those two values is because we want it to be more efficient. We want to know where the middle of the puzzle is. So the most iteration that this method will use is half of the puzzle. In no time, at no given time, will it iterate to the length of the puzzle. Hence, if the puzzle Hence, if there is 1,000 puzzle in the list, the most iteration it will do is 500. So we set the index to 0 for the iteration because we're gonna iterate. Now the selected index is for the selected puzzle. So the index is the amount of iteration we're gonna do to find the puzzle. So we initialize the index as 0. We also have the middle index, and we equal the middle index to the total amount of puzzle divided by 2, which, as I stated a while ago, if we have 1,000 puzzle, the middle would be 500. So there we found the middle index. We create a variable called greater than, we equal it to false. We create a node, instance of a node, equal it to the head. So we check. So we make our first check. If the selected index, which is the index for the puzzle that we selected, is greater than the middle index. So if it's greater than 500 per se, greater will equal to true. And the current will equal to the tail. That means we will traverse from the tail. So this is where I told you that we will only traverse to half of the puzzle at most. So if the index would equal, if the selected index was 501, we would traverse from the tail. So at that time, to traverse to 501, we will need 499 iteration instead of 501. So that is more efficient than traversing from the head. So if the selected index is 1,000, we would take 0 to 1. I think it's 0 because the index would be the tail, so we would take 0 iteration. So we would select the final the selected index instantaneously, which is 1,000. So it would just current would equal a tail, which is 1,000. So we wouldn't have to do any iteration here. So this is why this method is more efficient than any other method we could thought of. So selected index equal total puzzle minus selected index plus 2. This is the method we use to get to the puzzle. Note that this print statement was used to check the iterations. We commented them out for this purpose of the video. I think I'm gonna uncomment them so that when we run the game, we can see the iterations and the puzzle that is selected. So this show the middle index, this show the iteration need to find the puzzle, this show the total amount of puzzle, and this show the puzzle number selected. All are printed out. So don't think I have to go any further in detail with this, except for this one where we delete the selected puzzle. So node temp equal current. So you're gonna set the temporary, gonna set that a temporary node to current, and temp that get next. So temp that get next, that set your previous. So the next node, the node that's in front of the node that is in front of temp will set its previous. So if temp is 2, the next node will be 3. So this would say 3, set your previous to temp that previous. Temp is 2, so temp previous would be 1. So this is saying 3, set your previous to 1. So temp 3 previous is linked to 1. And it's now temp get previous, which will be 1, set your next to 10, that get next will be 3. So this is saying 1, set your next to 3. So there we have 3 linking to 1 and 1 linking to 3. And then we set current to null, deleting current and returning the value. So I guess it's time to run the game. First, let me go through the game manager class. This consists of all the functions for the game, including the artificial intelligence for the robot. I think I've just got to this. Okay. For the sound effects, these are menus that are printed out, show the game. So let's go. So at the main screen there are 3 options. Option 1, press enter to use the default player name, which are player 1, player 2 and player 3. This is if you and 2 other friends are too lazy to enter your own name. Option 2, press and then enter for new player names. Note that you will input your own names. And player 3, if there are only 1 or 2 players that want to play the game, so you are required to use a robot. So that's C. So since I'm the only one that's going to play a game, I'm going to use robots because the game required 3 players. So this asks how many robots you want to play against. So I'm going to play against 2 robots. So that's option 2. This screen asks for the level of difficulty ranging from beginner to legendary. I'm going to start off at the beginner level and enter my name.
The category is animal.
Note that these are the print statement that we just uncommented out. So this show the total amount of puzzle, which is 84 puzzle. The puzzle number is selected at 78, which we select puzzle number 78. The middle index is 84 divided by 2, which is 42. And the iterations need to find the puzzle is 6 to show how efficient that method was. So as you can see, the method iterate from the tail upwards. So in order to find puzzle number 78 or index number 78, it took 6 iterations. So that's good for efficiency. And this line shows the round number and the category. So the round number is 1, which is the first one, and our category is animal. This line shows the puzzle in which the user required to solve. This line shows the current player, and the details consist of his round total and his grand total. This is the option available. So I'm going to press enter.
$2,000.
Note that after spinning the wheel, it landed on a spot on the wheel. This line shows the current spot on the wheel, which is 15, and the type, which is money, value 2000. I'm going to check the card to see if that's consistent. Check again, spot 15, 2000, card 15, 2000. So that's consistent. So note that we had another option. This time we had an option to enter a letter. So I'm going to enter a C. Note that if there are any C in the puzzle, if there are one C, the C will be revealed. If there are no C, then the play will pass on to the next player. That means it will no longer be my turn, and then I will not have any money added to my round total. But if there are any C, the amount of C in the puzzle will be timed by 2000. So if there are one C, 2000 will be added to my round total. If there are two C, 2 times 2000 will be 4000 will be added to my round total. If there are no C, then I will not have any of this money added to my round total. My round total will remain at 0, and then the turn will pass to the next player. So let's go.
1 C.
So note that there are 1 C. This line shows the amount of letters in the puzzle. C in the puzzle are character letter that it gets in the puzzle, and they show the value. And note that it is added to your round total instantly. Your grand total remain at 0 and will only change if you are the person that solves the puzzle or guess the final letter, which is same as solving the puzzle, and the 1C is revealed in the puzzle. Now I have the option of spinning the wheel, type by to buy a vowel, or solve the puzzle. Note that I have to type the word by to buy a vowel, then press enter. It is not case sensitive, so it's not required to type capital letters. Even if you type capital letters, it still works. It works whichever case you type. So after pressing enter, it will ask me to enter the vowel. I'm gonna buy a A. Note that each vowel costs $100. So if there are one A, $100 will be deducted from your round total. If there are no A, then $0 will be deducted from your round total, and the play will pass on to the next player. But if there are A's in the puzzle, it will still remain your turn, and you get to guess a different letter or by another vowel, or you can choose to solve the puzzle. So I'm going to press enter.
4A.
Note that there are 4A and it costs $400. A moment ago I have $2,000. So as you can see, $400 was deducted from my round total, and the 4A has been revealed in the puzzle. It remains my turn, and I still have the option to spin the wheel, select the vowel, buy a vowel, or solve the puzzle. So I'm gonna buy another vowel since I don't know what the puzzle is, and my best options of getting closer to solving the puzzle is buying vowel.
1E.
1E.
900.
Note that I just choose to spin. Spot on wheel is 25, and the value is 900. Let's check that again. 25, 900, so good. Everything works fine. So I have the option to enter letter or solve the puzzle. Since I spin the wheel, the only options available after spinning the wheel and having a round total greater than 0 is enter a letter or solve the puzzle. If your round total is 0, the only option after spinning the wheel would be enter a letter, since you can't solve the puzzle if you don't have any money in that particular round. So I'm going to enter a letter. So the animal, I'm going to enter a B.
2B.
2B in the puzzle. Know that 2 times 900 is 1800, which is added to my round total. I'm going to spin it.
2500.
2500. I think I'll take a L.
1L.
on L. I'm gonna spin again.
500.
Take a S.
2 S.
Alright, before I spin again, if I lose my turn, this game might move a bit fast. And due to the sound effects, I may not be able to explain what's going on at the moment because the sound effects may overpower my voice. So if I choose to spin the wheel and it landed on lose a turn, which is a spot on the wheel, which is right here, that's value $0, lose a turn. If it's landed on lose a turn, then I will lose my turn, but I will still have my round total. So the player will pass on to the next player, but I will still have my round total. If it landed on bankrupt, that's where I will lose all the money that's accumulated in the round. But bankrupt doesn't affect your grand total, it only affects your round total. So I lose all the money in the round and then also lose my turn. So the play will pass on to the next player. So I like to state that before I spin the wheel.
2000.
So I guess I still have my turn, so I'm gonna enter a key.
2K.
I'm gonna spin again since I
800.
alright. M.
2M.
Oh. Now I'm gonna try to solve the puzzle. As you know that I have three options, one of them solve the puzzle. So in order to solve the puzzle, which is stated in the user manual, you have to enter all the letters in the puzzle, including space or symbols. So if the puzzle has a comma in it, you have to include the commas, else your guess will be wrong. So I'm gonna enter the puzzle. Note that it's not case sensitive. So that's first word black, then space, AMBA, then space, SNAKES. Then press enter.
The category is place. 500. 600.
Okay, those were the robots taking their attempt at the puzzle. As I stated that the game might move a bit fast when playing with the robots. Okay, now it's my turn again. And note that after solving the previous puzzle, all the money that's accumulated in the round was added to my grand total, and my round total was reset to 0 in order to play the next round. Okay, so I'm gonna press enter.
850. 2S. 600. 2R. 500. 600. 1T. 2I. 700.
Alright, as I stated earlier that these two lines track the previous guess and the vowel. So these are the letters that we already used. These are the vowel. Note that robots are able to buy vowels also. If you realize earlier when the robots were playing, the word buy pops up on the screen. So the robots are some artificial intelligence that help them to purchase vowels to add a buzz to this game. So it's my turn again, so I'm gonna spin the wheel.
700. 1 A 1 O 850. 1 B 2500. 2 N 3 E. The category is thing.
Alright, note that the robot win that round, so we are at the final round, which is round 3. The category is thing. And again, the amount of puzzle is 82 because, as I stated earlier, that we remove the selected puzzle from the list so that we don't select the same puzzle more than once. So we have 82 puzzle. The puzzle number selected is 42. The index is, middle index is 41, which is 82 divided by 2. And the iterations needed to find this puzzle is 41. Since this is not greater than half, so it traverses from the head. So it took 41 iterations. Know that if the puzzle selected index is greater, it will be the least amount of iteration. So I'm gonna spin.
600. 600. 1 E 500. 3 N 2 I 1 8 600. 1 L 700. 1 C 800. 2 T 800. 1 R 6 O 800. 1 K 650. 1 F 700. 1 M 1500. 1 Y
Wow, for a second I thought I was gonna lose a beginner to a robot. This robot was going well, so 5,000 plus that would have added into 11,000, which I still would have won. So note that the robot has bankrupt. Spot and wheel is 16, bankrupt. Let's check that one more time. 16, bankrupt. So all the money that he had accumulated in that round, he had lost. So it's my turn to redeem myself and win this game.
600. 900. 1 H
Okay, I lost my turn a while ago. Note, doesn't affect my grand total, and the bankrupt didn't affect the previous player grand total. It only remove all the money from his round total. So
650. 1. G.
so I guess I already know this informational technology book, so I'm gonna just buy an E and complete this.
1. E.
Alright, note that this is all the calculation. So we have bot 1, bot 2, and me. So this is the number of rounds won. Bot 1 win 0 round, lost 3 rounds since 3 rounds has played. Bot 2 win 1 round, lost 2 rounds since 3 rounds have played. That's consistent. And I won 2 rounds and lost 1, in which bot 2 won. So this is the grand total. Grand total of 0, grand total of 5,750, grand total of 12,950. So as I stated earlier, that the person with the highest round total will be the winner, as stated here. Now we have come to the end of the game. We have two options: to play a new game or exit. Now I'm going to choose exit. If you want to play a new game, you can press 1. So that's it for today.